This is concept 44. In this one, the main ideas here are the three properties for log expressions. The first one is the product property. When you have the log base b of two numbers that are being multiplied, we can write this as log base b of m plus log base b of n. So whenever you have a product of a log base b, a product of two values, okay, you can go from multiplication to addition. So right here it says condense into a single logarithm, simplify if possible. So we rewrite the two logs into one log. So they give us this form, we have to go over to this form. So again, multiplication to addition, or addition to multiplication. So here I have log base 2 of 7 times 4. And again, I'm just reversing the property. So this is equivalent to log base 2 of 28. And we're done. This is my answer. Number 2, I have log, and remember, when there is no base given, we assume base 10. This is log base 10 of 25 times 4, and we can simplify that to log of 100. Number 3, I have log base 4 of 2 of x plus log base 4 of 4x squared. So I can rewrite this as log base 4 of 2x times 4x squared. And then that's equal to log base 4 of 8x to the third. I multiply those, and that's my answer. For numbers 4 through 6, I am going from this form to the bottom one here. So I'm going from multiplication to addition. Now in this case, I'm given only one number, so this can be kind of confusing, but you can express this number, so 6, 45, 5x, as a product of two values. So, and right here the answers can vary, because I'm going to rewrite this one as log base of 2 plus log of 3. Why? Because 2 times 3 gives me 6. You can also have 6 and 1. So again, your answers can vary here. Okay, but this is correct, as well as log 6 plus log 1. Number 5, I can rewrite this as log base 7 of, and then take any two factors of 45. We can do 5 and 9. So log base 7 of 5 plus log base 7 of 9, because 5 times 9 is 45. And then this is done. And like I said, you can have multiple answers. 15 and 3 works, 45 and 1 works, and so on. Next one, I can write this as log base 2 of 5 plus log base 2 of x, because 5 times x is 5x. Okay, so that, or these are the examples showing the product property. Next is the quotient property. When you have division, log base b of m over n, you can express this as log base b of m minus log base b of n. So what you have to memorize is, again, multiplication goes with addition, division goes with subtraction. So right here it says condense into a single logarithm, simplify if possible. Okay, so I'm giving this form here, okay, this form here, and I have to rewrite it to the top form. So I have log base 3 of 24 over 8. So m is 24, n is 8, and then I can simplify that now as log base 3 of 3, and I'm done. 24 over 8 is 3. Next one, I can write this as log base 2 of 15 over 15, and that's equal to log base 2 of 1, and that's it. Next one, I can write this as log base 4 of x to the 9 over x squared. And then you'll recall from our last unit on rational exponents, x to the 9 over x squared, this can simplify to log base 4 of x to the 7. For numbers 10 through 12, we're going from this form to the bottom form, so from division to subtraction. So some of these values, well, actually just number 10, you're gonna have to just assume that you can rewrite this one as some ratio. Okay, so there's multiple ways you can express 4. There's an infinite amount of ways. So we can just take 8 over 2, and again I'm just rewriting 4 as 8 over 2, and now I can rewrite this log, I can expand it and apply the quotient property. So I get log base 8 of 8 minus log base 8 of 2, and that's my answer. Next one, it is a ratio. I have 1 over 3. So I can rewrite this as log base 5 of 1 minus log base 5 of 3. And next one here, I have m over 7. This one is the common log base 10, log of m minus log of 7. And that's it. For the next one, we have the power property. Whenever you have an exponent, so the log base b of m to the n, what you do is you move the exponent to the front of the log, so it becomes a product of that exponent times the log. So it's n times log base b of n. Whoops. So again, all you do is move the n to the front of the log. So this one says condense into a single logarithm or just simplify it. So I have a 5 in the front. I can rewrite this one as log base 4 of 2 to the 5th, and I can simplify that further. 2 to the 5th is 32. Number 14, I have log base 2 of x times 7, so I can move that as the exponent, x to the 7, and then there's nothing further I can do, so I'm done. Next one, I can write this as log of 8 to the 1/3, and from our previous unit we know what fractional exponents those are. You can rewrite those as radical expressions. So this is 8 to the 1/3, that's the cubic root of 8. The cubic root of 8 is 2. So let's make a note here. 8 to the 1/3, you can rewrite this as the cubic root of 8, and we know that's equal to 2. So this is log of 2, and that's it. Next we go we expand using the power property. So it just involves moving the exponent over to the front, so going from this form to the bottom form here. So 7 times log base 2 of 8, and that's it. For this one, I already have a 3 here in the front, okay, but it still works the same way. We can move this over to the front and then simplify anything we need to do. So I get x minus 1 times 3 times log of 4, and then right here in the front I can distribute the 3 into both terms, so I get 3x minus 3 times the log of 4, and then you can put a parentheses, and we're done. Next one, this is a square root, so I can rewrite this as log base 7. I'm going to rewrite this as a exponent so we can see what it is. I have a w to the half. So, and now I can move that exponent to the front. So I get 1/2 times log base 7 of w. And that's my answer. So one thing I noticed while I was doing this lecture, this video right here, number 11, you can also rewrite this. You can rewrite 1/3 as some other expression, so you can have like 15 over 45. Okay, and then you can also have, you know, log of 15 minus log of 45. All these answers here, of course, can vary because you can, like I said earlier, you can rewrite some of these as the same expression, just as a bigger ratio. Okay, but it would they would still be correct. And this here should be log base 5. Moving on to the next page. Says putting it all together. So these examples is just like, you know, it applies, or we have all the properties here. We just need to know which one we are using. The directions say rewrite as a single logarithm, simplify if possible. So for this first one, just watch out for parentheses. The 2 does not apply to both here, so it just applies to log base 6. So I can rewrite this as log of 6 squared minus log of 9, and then I can write that as log of 36 minus log of 9, and then because I have subtraction, I know this is the quotient property. This one here, I'm going from here to here, so I can rewrite this as a ratio, log of 36 over 9, and then that simplifies to log of 4. And here I finish. Next one, I have 4 times log base 4 of a, so I write this as log base 4 of a to the 4th plus log base 4 of b squared. I move the 2 as the exponent for b. Then I have addition, so I can rewrite this. This is the product property, so I can have log base 4 of a to the 4th times b squared, and I can't combine further, so I'm done, or I can't do anything further from here. Number 21, I have 7 times this log, 3 times this log, so I can rewrite this as each one with its respective exponent. So u to the 7 minus log of 4, whoops, I misspelled this, log, sorry about that, log of 4 of v. I have v squared, and if I move the 3 to as the exponent, I get 2 times 3 in the exponent, so this is v to the 6. Then I have subtraction, so I can rewrite this as a quotient, so u to the 7 over v to the 6, and then I can't simplify anything further from there, so I'm done. Number 22, I have 3 logs, okay, and it works the same way, go left to right. Okay, so I can rewrite the first 2, it's addition, so I go to multiplication, so I have log base 2 of 15 times 4 minus log 2 of 6. Then I can now I have 2 logs, I have subtraction between them, so I can rewrite this as a quotient, and I'm going to simplify what would be the numerator, log base 2 of 15 times 4, that's 60, okay, over 6. And then I can simplify here, 60 over 6 is just 10, so log base 2 of 10. 23, 3 logs again. I have one that has a constant in the front, so I'm going to move this as the exponent, and then let me rewrite, okay, let's rewrite the first 2 here. So log base 3 of 4 plus log base 3 of y, we have multiplication, so I can rewrite this as log base 3 of 4y plus, then if I move the half to the exponent here, I get 49 to the half. Okay, 49 to the half, we know this, that you can write that as a radical expression, square root of 49. Square root of 49 is 7. So this is equivalent to log base 3 of 7. I have addition again, so I can now combine these using the product property. Log base 3 of 28y. And I'm done here. 24. Now I have a parenthesis, so the 1/3 applies to both of these, and then minus log base 5 of 3. So I can distribute the 1/3 to each one, and then rewrite each of those as to the 1/3 power. So I have 1/3 times log base 5 of 8 plus 1/3 times log base 5 of 27. So let's rewrite that. 1/3 plus log base 5 of 27 to the 1/3 minus log base 5 of 3. Now we have we can rewrite these as radical expressions. I have the third root of 8, the cubic root of 8. We've seen that already earlier, and we know that's 2. The cubic root of 27 to the third is a cubic root of 27. I can rewrite that as 3. So this is log base 5 of 2 plus log base 5 of 3 minus log base 5 of 3. Left to right, this here I can multiply, so I get log, running out of space here, so I have log base 5 of 6, because 2 times 3 is 6, minus log base 5 of 3. Then I'm going to divide, because this is now minus, so log base 5 of 6 over 3, I get log base 5 of 2, because 6 over 3 is 2. 25. I have just two terms. This one becomes the exponent for this one, and then it's not parentheses like this one, so it's just log base 32 here. And I have minus, so I have log base 2 of 4 to the third over 32. 4 to the third is 64. So log of 2 of 64 over 32, and that simplifies, so log base 2 of 2. Next one, I have the common log, and each one has its own, well, except the last one, but this one has 1/4 as its exponent, and this one has 2. So I can rewrite this as log 6 squared minus log of 16 to the 1/4 plus log of 3. This is log of 36 minus log of 16 to the 4th, and again this is the 4th root of 16. The 4th root of 16 can be rewritten as 2, because 2 to the 4th is 16. So we can make that note here, maybe on the side. 16 to the 4th is equivalent to the 4th root of 16, and that's equal to 2. Plus log 3. This is minus, so I can rewrite this as log of 36 over 2. Log of 36 over 2 is log of 18 plus log of 3, and then this is now plus, so I can rewrite this as log of 18 times 3, and then 18 times 3 is 54, and that finishes this part. For the next one, we work backwards. We got to expand each one. Just pay attention to the whenever there's exponents, to which term it applies to. So right here we have 3 multiplied together, but the 4th power here applies only to the z, that's z to the 4th. So I can rewrite this as, and we're multiplying, so we got to work backwards, and it's addition. So log base 6 of x plus log base 6 of y plus, and then I'm going to skip a step. It would be log base 6 of z to the 4th, and because we have an exponent we can move it to the front. So 4 times log base 6 of z, and that's that would be it. Next one, we have division or quotient. We can rewrite this as a difference of logs. So log base 4 of a to the 9 minus log base 4 of b. This one has an exponent, so I can move it to the front. 9 log base 4 of a minus log base 4 of b, and that's it. Next one, I have log base 7 of q to the 4 times r squared, all that squared. So this time the exponent out here, the 2, applies to both. So multiple ways I could go about this. Maybe the best I can do is move it to the front. Log base 7 of q to the 4 times r squared. So let's look at it this way. Let's show every step. Then here I can expand this one. It's a product, so I can go to addition. So 2 times log of 7 of q to the 4th plus, and we need a parenthesis because that 2 applies to this entire log here, plus log base 7 of r squared. We have that there, and then within the parentheses I can move those exponents to the front of the logs. So I have 2 times 4 log base 7 of q plus 2 times log base 7 of r. And the last thing I can do here is distribute now the 2 into both of these. So I have 8 log base 7 of q plus 4 log base 7 of r. Okay, and that's that. For this one, okay, properties of exponents. Again, multiple ways you could go about it. I'm going to take the same approach here, and I'm just going to move the exponent first to the front and distribute later. So I have 2 log 2 of y, I need the parentheses there, minus log base 2 of z to the 5th, and then I can move this exponent to the front. So I have 2 times log base 2 of y minus 5 log base 2 of z, and then I distribute the 2 into both terms. So I have 2 log base 2 of y minus 10 log base 2 of z. Almost there. Right here I can rewrite the square root of 7x to the 3rd as log of 7x to the 3rd to the 1/2, right, because that represents square root. Now I can move this exponent over to the front, so I have a half of log of 7x to the 3rd. This is a product of 7 times x to the 3rd, so I can move that now, or make that into a sum of 2 logs. So 1/2 times log of 7 plus log of x to the 3rd. This is a exponent. I can move it to the front of log. Okay, I'm going to move here because I'm running out of space. So 1/2 log of 7 plus 3 log of x, and then I can distribute that half into both. So I have 1/2 log of 7 plus 3 over 2 log of x. Finally, the last one, I have the 4th root of m to the 5 n squared. I can write this as log of 3 of m to the 5 n squared to the 1/4. That would be the 4th root. Then I can move the 1/4 over to the front, so I have 1/4 of log, I'm going to use my parentheses, log base 3, and I'm going to split because we have a product here, so it becomes addition of m to the 5 plus log base 3 of n squared. I can move each of these exponents now to the front of the log, so I get 1/4 5 times log base 3 of m plus 2 times log base 3 of n, and then finally I can distribute the 1/4 now into both terms, so I have 5 over 4, that's a 5 over 4 log base 3 of m plus 2 over 4 log base 3 of n. One more thing I can do here is simplify this one here. Okay, so my final answer should be 5 over 4 log base 3 of m plus 1/2 log base 3 of n. And then that's that there. And that wraps up concept 44. This next sheet here is a graphic organizer just kind of summarizing part of concept 43 and concept 44. This is the sheet that I'll let you use for your test. So back to concept 43, we showed that when you have the log base b of b, the same two terms there, you're going to get 1. Log base b of 1 is always going to be 0. Okay, and then the idea here is, and these examples here will show what these mean. Okay, so what you're saying here is that if you make this an exponential expression, okay, so 14 to some power is equal to 14. 14 to 1 to the 1 will give you 14, so any base to the 1 power is always going to give you that same base, so it's 1. Here you'll push this over to the side here, so you get 3 to the x. 3 to the x is equal to 1. Any base to some exponent to give you 1 is going to be 0. Okay, anything to the 0 power will give you 1. This is the product rule that we just worked with. This is going to be equivalent to log base b of m plus log base b of n. So remember, multiplication goes to addition. So condense this, I get log base 5 of 6 times 7, so that is 42. Here, expanding, I can rewrite this, and again, there's multiple ways depending on the number of factors here. So I can rewrite 63 as any 2 factors, so log base 2, and I'll take 7 and 9, because 7 times 9 is 63. So log base 2 of 9. The next one is the quotient rule. This one is quotient to division, so log base b of m minus log base b of n. And right here I can rewrite this as log base 4 of 84 over 12, and 84 over 12 is 7, so log base 4 of 7. Expanding this, I can rewrite, so it's just a term 9. I can rewrite 9, so let me write it here in the corner, as just any ratio. Again, there's multiple answers here. I'll just take 81 over 9, because 81 divided by 9 is 9. So this is equal to log of 81 minus log of 9. That's it. The power rule, you bring the exponent to the front, so n times log base b of m, condense, so make this easier. I can write this as log base 3 of 8 squared, and that's equal to log base 3 of 64. Expanding, bring the exponent over to the front, so I get x minus 1 times log base 2 of 6, and that's it. The change of base formula, remember you take so I have log base b of a, this is equivalent to log of a over log of b. Okay, using a common base, evaluate the expression below. I can rewrite this as log of 32 over log of 7, and then you use your calculator for this and you get 1.7810. And you use change of base formula when you realize that rewriting it into an exponential expression, that exponent isn't so obvious. When that happens, that's when you have, more than likely, you have change of base formula. And then finally, the bottom here, remember that base 10 logs are common logs, and those are the ones that are written without a base. So whenever you see just log of x or log of some value, we're talking base 10.